All right, guys, today our lesson is on adding linear expressions, in case you didn't know that. All right, so with adding linear expressions, right, there is a little bit of subtraction in it, but we know what adding is, right? We know what expressions are. The whole chapter is about it, but the word linear kind of is a little different, right? So that's, of course, where our vocab word comes from. So our phrase is today linear expressions, everyone.
Linear expressions.
All right, here we go. Your book says this is an algebraic expression in which the variable is raised to the first power and variables are not multiplied nor divided with each other. All right, so in your little box here, I'll talk about it more in just a bit, but here are some examples. All right, so the first two are examples. So 5x, all right, that could be a linear expression. Because if you take a look, right, it's raised to the first power. If you don't know what that means that it's x to the first power, which we never really put a little 1 up there as an exponent. All right, so that's what it means by that. And it says variables are not multiplied nor divided with each other. So it's just the variable multiplied with its coefficient. All right, so the other one is 3x plus 2. So again, variable to the first power, variables not multiply with another variable. Those are a couple of examples of linear expressions. Okay, if you want to know something that wouldn't be a linear expression, here's what it's talking about. Something like 5mn. Okay, 5 times m times n, or 3x cubed plus 2, 3x to the third power, right? The variable's not to the first power, it's to the third. So those would be things that are not linear expressions, all right? So just if you might want to be like, well, why are those even called linear expressions? Okay, well, just where you know, all right, let's take a look at this. Who can tell me, those of you that are good in AB with vocab, what would be like the root word to the adjective, right? Linear is describing the word expressions. What would be the root word to linear? Anybody know? Line, yeah. It is a line. So here's why I'm telling you this, is because as you get older and you get into 8th grade and even into high school, you guys are going to be doing something that this is going to expand on. You'll be getting into things called like linear functions, for example. Okay, and you'll have these equations that look very similar to this. And what that means is that when you actually take a coordinate graph and you graph these expressions or the equations, the functions, it's going to create a straight line. Okay, so that's basically what that is. All right, so that's what we're talking about. Now, all this is just a lesson that goes along with everything we've been talking about with expressions, but it just gets you ready for the next level. Okay, so when you guys get to 8th grade or 9th grade, you'll be able to see these sort of things and know how to do it. Okay, so with that said, let's go ahead and grab our worksheets. Get your name up at the top. Name, date, period. Okay. This is a pretty quick lesson because we're going to go through pretty much one type of problem and you guys should be okay after that. So here we go. Let's take a look at problem number 3. Okay. Okay, problem number 3, here's what I want to point out to you guys to start this off with. Okay, the directions say add, use models if needed. Okay, well what we're going to do today is I want to show you, look at this. That in those set of parentheses, that's a linear expression. This in this set of parentheses, a linear expression. And therefore, when it says adding linear expressions, the name of our lesson, right? there's the addition sign. If you take a look at every single one of these, they all look very similar. Okay. Now, what we have is we have negative 3x plus 15 plus negative 3x plus 2. Okay, when I go to solve this, if you remember right, we talked about, and reviewing again, right, simplified expressions are any expressions that do not have parentheses and no like terms. Okay, well, we have a problem here because it has both, right? Now, when we get rid of parentheses, and this is very much like the problem we did on Friday, bless you. The problem we did on Friday had a couple of set of parentheses, right? And then we did talk about on that one problem that when you have parentheses like this, we see if there's nothing in front, we talked about how you could squeeze a 1 in the front. And even up here, you could squeeze a 1 up in the front, right, to do our distributive property. Now, if you take a look here, and you don't necessarily have to write this part down, but if you take a look, if, let's just take this second half, if I was to do distributive property here and multiply this positive 1, just as 1, with negative 3x, what would be our answer, guys? Negative 3x. Why? Because anything we talked about in our property lesson, right? Anything multiplied by 1 is itself. Now, here's the whole point of me telling you this. Because this is a positive 1, basically because of the addition sign, we're going to save ourselves time. Because it's positive, we don't need to do distributive property multiplying everything by 1 because it's going to end up the same anyway. So the nice part about this lesson is, and this is, go ahead and grab your pencil, this is step 1, is when you are adding two linear expressions together, it's creating two basically positive 1s in front that you can multiply by. You don't have to do any distributive property. We're going to kind of cut out the middleman, save ourselves some time, and all we're doing is we're dropping parentheses. So when we have this, we have, instead of writing the parentheses, I'm going to put negative 3x plus 15. Now I could put a double sign here. I'm just thinking ahead. I could put plus negative 3x. But instead, since we're 7th graders, let's just go ahead and get rid of it and just keep our negative 3x here plus 2. Now, what we see here is we pretty much see our POD. This was our POD. It's actually a little simpler than our POD. So here we go. Step 2 is I'm going to go ahead and I'm going to combine like terms. So I start with my x term up front. So I have my negative 3x. I'll just choose to box it in. Look for all my other x terms. I have one right there. This here is 3x, but be careful, it's minus 3x, so include the sign. That gives it a negative 3x value. No other x terms, so now I go to my next type of term, and this is just plus 15, which is a constant. I'm going to go ahead and circle it. And then my only other term that I haven't done anything to is also a constant, so it's a plus 2. I'm going to circle it. So when I combine, I have my boxes here, which are my x terms, negative 3x minus 3x, or negative 3x, or sorry, negative 3 minus 3, which we know is negative 6. Don't forget your x, negative 6x. So I go ahead and combine my coefficients. And I have positive 15 plus 2, which is 15 plus 2 is positive 17. And ladies and gentlemen, when I look at this, I'm thinking, well, no parentheses, no like terms. Guess what? That's our answer. Okay, we're going to add on to this, of course, in future lessons. But for right now, that is really what you need to worry about today. 2 easy steps. All right, because it's adding linear expressions, right? You drop parentheses and rewrite it. And then all you have to do after that is combine like terms. Okay, before I give you guys one to try, any questions? Okay, so great question, right? Because some of us are still kind of getting confused with integers. All right, the question was negative 3x and a negative 3x. since they're the same, wouldn't it be positive? Remember, that's multiplication and division. Okay? So again, guys, even though it's called adding linear expressions, we're basically combining all of these, right? Combine like terms, adding and subtracting. Anytime you add and subtract, if it makes you feel better, right, go back to the T-chart part. Remember, two negative 3's put together, or I should just say a 3 on the negative side and another 3. Remember, you add them up and it's a total of 6 negatives. Okay, or of course, you think about having our tiles, right? Our integer tiles at the start of the year, 3 negatives and another 3 negatives would be a total of 6 negatives. Okay, good question. Guys, other questions?
It's not a question, but this is from one of your period ones, I think.
Okay, here we go. Here's the problem I want you guys to try out. Try out problem number 13. 13. All right, go. John, you got it. 13. Okay, how many of you need more time? Okay, a few more seconds, and then those of you that are done, you can go ahead and try some others. All right, continue on your homework. That's step 2. Okay, 30 seconds. All right, here's what I'd like you guys to do, is to go ahead and when you explain it to your neighbor, okay, when you explain it to your neighbor, your partner, I would like you to go ahead and you can start with your answer, obviously, but what I'd like you to do after that is to go ahead and make sure, I want you guys to compare work. Make sure that your neighbor, when they're boxing or putting a triangle around it or circling, make sure they're also putting their sign in front that is in front of their term, all right? The addition sign or subtraction sign, right? So to the left, all right? So when you're looking at that, make sure you're double checking. Okay, then you can either the 3 of you or the 3. Okay. So go ahead and 30 seconds, turn to your neighbor and share. Go. Guys, those are people. There's a lot of people absent. Please make sure everyone is involved.
I boxed 4x and negative 5x and circled negative 1 and plus 17. And then for this box variables, I got negative 1x, and then for the other one, I got plus 16.
Okay. I got negative 1x plus 16. I took on the variables and boxed in 4x and negative 5x, and then I also circled negative 1 and 17, and then I did the x's and I subtracted them, so I got a negative 1x and added.
Okay.
And subtracted.
So here is what I'm going to do. We're going to have time to do whiteboards today, so whenever I check your whiteboards, I'll be looking for the boxing and circling. Okay, so for right now, all I want to see is what your final answer is, your simplified answer. All right, so here we go. Seat number, oh, not in this class. Neither is that one. All right, seat 4. Okay, you talk to John about it when you guys shared. You start doing your own task. Okay. All right, seat 19. Okay, negative 1x plus 16. You could even say, right, negative x plus 16 would be, an equivalent expression. Okay, agree, disagree with that answer. What do you guys have? Okay, all right, it's almost everyone. So here we go. Here's what I'd like to do is I'm going to go ahead and give ourselves some extra room here. Let's see if you guys are correct. I'm going to rewrite it over here. So I have, drop in the parentheses, right? Step 1, so 4x minus 1. Going to try to get rid of the double sign. If I don't get rid of the double sign for right now in my work, that's okay. I could put my plus and my negative 5x plus 17. But that's okay because when you do this next step, all right, by boxing and circling, you're going to see the double sign's not going to matter if you do it right. So here we go. I'm going to go ahead, box in my 4x. All my x terms, 5x, remember, it's a negative. You only box in, if you're careful, you only box in the sign to the left, as long as it's not a double negative, right? But it's not, so I just box in that sign there. Now what I have is I circle my negative 1, my constant, and I circle my positive 17. So what I have is 4 minus 5 is, that's how we would get our negative 1x, or negative x. And negative 1 plus 17 is plus 16. All right. Well done, ladies and gentlemen. All right. Questions before I'm going to let you guys try out a problem on whiteboards. Questions?
Oh yeah, I have a question about homework. What does it mean by like 5 through 6 on the homework?
5-6. Remember? Chapter 5, lesson 6.
Oh, okay.
Okay, really quickly, I want to take this time really quickly, guys. Number 17, here's what I want you to do. Okay, they actually put an equation on here, and that's next chapter. We haven't gone over that in this class yet, so I'm not going to make you guys do that. So in this case, you can do the rest of this on number 17 here, but you don't have to do that last part. Okay, if you want to try it, you can. All right, I'll give you the answer, but it won't count towards your grade. I'm just checking problem number 17, okay, on the very start. And just kind of keep in mind, guys, 17 and 18, they're word problems, but they're asking you to write an expression that will look like this, okay, because it's all about adding linear expressions, and then you'll simplify it the same way. Okay, 2 minutes. Go ahead and whiteboard monitors, grab whiteboards, make sure 8 of everything is there, please. 2 minutes, go. Right now would be a time. Yep. Make sure you sign out. Go, go, go.
Mr. Wiggins, can I trade
The dead?
what's
No, let me see on the whiteboard.
Yeah, around it.
All right, there's a whiteboard. Check it. All right. That's still good for right now. It's a horrible whiteboard to use that pen on, but it should be okay for maybe 1 or 2 more periods.
what?
Show me on your whiteboard. Tip it straight up and down. You should be able to still write. There you go. All right. At this point, guys, make sure whiteboards are erased. Name is down at the bottom.
It's actually dead now.
Okay, just do it on a piece of paper then from on your homework is fine. Okay. Thank you, those of you that have your names down at the bottom and are ready. Okay, on your whiteboards, guys, try not to do, if there's a double sign that pops up, right? Double negative, of course, you know, convert it, make it into the large plus sign, but if it comes up as a plus negative, try to simplify it by having just your single sign, okay? Also, make sure that you show your work properly, all right? I want to see, you know, boxing, circling to show what your like terms are, as well as, of course, the sign inside that box or circle, okay? So make sure that you're careful with that, all right? And then, of course, make sure your answer is clearly on there where I can check. All right, you guys ready? All right, here we go. Problem I want you guys to try out is problem number 11. Number 11, go. Okay. Thank you, those of you. Remember to just put it up as soon as you're done. Remember, guys, when I check your board, if I okay it, you can get going, transfer it to your homework, and then get going on your homework.
Bless you.
Check your constant, your number without the variable. Use a T-chart. Okay. Okay, guys, eyes up here. Okay, if I okayed your board, all right, transfer your answer over with your work, and you can get going on your homework. Those of you that did not okay your board, or I gave you some feedback, depending on what it was, I want you to look up here as we do this. Okay, don't erase your whiteboard. Set it off to the side. Grab your paper. Grab your pencil. Let's do the homework together right now. All right, so